Today we are preparing for section 5.1 by practicing some of our algebra techniques and solving for a variable. In each of these we're going to practice solving for y. So for this first one, we want to remember to undo all of our operations. So if we see 2 times y plus 6, we want to subtract 6 from both sides. Then we're looking at 2y equals x minus 6. And so the next step, since it's 2 times y, would be to divide by 2 on both sides. And so then we get y equals x minus 6 over 2. Now, if we want to simplify this a little bit more, we distribute that divided by 2 to both of these two terms. And we get x divided by 2 minus 6 divided by 2, which of course is then 1/2 x minus 3. So there we have it, y equals 1/2 x minus 3. We have solved for our y. Now with this next one, we need to move our x term to the right-hand side. And so let's subtract 3x from both sides. And we have negative 2y equals 12 minus 3x. Divide both sides by negative 2. And we get y equals 12 minus 3x over 2, which again, we're going to distribute that divide by 2, and we get 12 over 2 minus 3x over 2. This, of course, then simplifies to 6 minus 3 over 2x. So there's our next example of solving for y. Now in this next one, we have y cubed minus 5 equals x. So of course, we're going to add 5 to both sides. We get y cubed equals x plus 5. Now, when we have something raised to the third power, to undo it, we take the cube root. So we have a little 3 in the pocket in the front, similar to a square root, only this undoes it by the third power. So then our cube root and our y cubed cancel. We get y equals the cube root of x plus 5. And that's it for this example. Now we have a couple fraction problems to handle. So we have 3 divided by y plus 1 equals x. Easiest way to undo the fraction is to multiply both sides by the denominator. That essentially is multiplying the y plus 1 to the other side. So now we have 3 equals x times y plus 1. That means 3 equals xy plus x, right? I can distribute my x to those two terms and break up the parentheses. Now remember, we're trying to get y alone, so let's at least subtract the plus x to the other side, see what we get. So if we subtract x, we get 3 minus x equals xy. So now we're closer, but we still have an x times y. Well, in this step, then we can divide both sides by x, and we get y alone, and we get 3 minus x divided by x equals y, and there we did it. So all we had to do was multiply our denominator to the other side, distribute our x terms to both the y and the plus 1. Then we wanted to move our plus x to the other side, that way we have xy alone on one side. And we're one step away, we just had to divide by x. So fractions look a little bit trickier, but just keep using your standard algebra techniques. Now we're going to do the same thing with the next example. We're going to multiply both sides by y minus 2. Both sides by y minus 2. And now we have y plus 4 equals x times y minus 2. Okay, we got to keep trying to get y alone. Now we have y's on both sides. So let's distribute our x term first. So that'd be xy minus 2x. And now let's move all our non-y's to one side and y's to the other. So I'm going to add 2x to both sides. And I get y plus 4 plus 2x equals xy. Okay, so now we're close. We have most of our non-y terms on the left, and we want to move all of our y terms to the right, so we're going to subtract y. And then we're going to have 4 plus 2x equals xy minus y. Okay, so now all of my y's are on one side. Each term has exactly one y. So now I can write 4 plus 2x equals y parentheses x minus 1. Essentially, I can factor out the y from both of those two terms. If I factor out a y from xy, I have x. And if I factor out a y from the minus y, I have a minus 1. Now we're one step away from getting the y completely alone. And we get 4 plus 2x divided by x minus 1 equals y. So it's a little bit extra work, but at the end of the day, it's still just moving your terms around and trying to get y alone. So there's a bunch of practice problems down below of that type. So I highly recommend that you go through these. There's a lot of them just so you can practice the different versions, whatever you need practice with. So please give those a try. Now on to the next example, I want to remind you of composition of functions. So remember that sometimes we plug one function into another one and we simplify to see what we get. So if I have f of g of x, then I am plugging g of x into f of x. So f of g of x is equal to 2. Now in place of the x, I plug in g of x. X minus 3 divided by 2 plus 3. Okay, so now let's simplify. I have a times 2 on the outside that's going to cancel with my 2 in the denominator. And I get x minus 3 plus 3. And the minus 3 plus 3, of course, cancels, and I just get x. So f of g of x simplified all the way down to just x. Now let's see what happens when we look at g of f of x. So if I take g of f of x, I'm plugging f of x into g of x. So now instead of x minus 3 on the top, I have 2x plus 3 minus 3 on the top, divide by 2 on the bottom. So then, of course, my plus 3 and minus 3 cancel in this example, and I have 2x divided by 2x divided by 2, and the 2's, of course, cancel, and again, I have just x. So these two happen to equal the same thing, and they reduced all the way down to x. And that's because f and g are actually what we call inverses of each other, and that's the kind of example that we're going to be focusing on in section 5.1. So give it some practice. Some of the examples down here in part 2 of our practice problems will simplify down all the way down to x, and some of them won't. And you'll be able to identify which ones are inverses and which ones are not. You'll see more details about that during lecture as well. So as always, please give these a try and reach out if you have any questions.